Hello, everybody. I know these videos are becoming pretty infrequent and kind of random at this point. I guess there's not really much of a cadence or a consistent rhythm. And I think just when it comes to my own creativity, I've grown to realize that I definitely go off more of the inspiration and certain interests that happens around me versus kind of just constantly trying to search for something to talk about every week. It's not authentic. And so I think with me exploring my own creativity and exploring my own content and how I want to do it, I definitely value just only sharing the things that I find interesting. So that's kind of why I do these infrequently. It's kind of just whenever I find something interesting or have an interesting ideas that I want to share. That's kind of when you'll find me doing a video. So just know that whenever I do a video from now on, it's definitely something important to me that I kind of want to share with you guys that's possibly important to you. And today the thing is that we're going to talk about is uh, open source versus closed source and how to compare the two when it comes to analyzing um, not just biotech or clinical information, but also it can be used as a general use case. But today I'm going to make it specific to biotech, clinical spaces, and kind of life sciences. At least we're going to use that kind of documentation to explore this use case. So, two things that I kind of want to give an example of and share ideas of is open source, and I have my board here. Open source versus closed source, and the difference between the two. So, let me put this line down here. There you go. So we can say open source is things like Deepseek. Deepseek. Or Meta Llama is another one. Nemotron from NVIDIA is another one. These are all very low cost models. Quen, I think, is another recent one that's been making waves. These are all low cost models. These are not only low cost, but you can also add them locally to your PC, your Mac, your computer, whatever you're using, and not have to kind of pay a lot of these big name models like OpenAI, Claude, Gemini for model usage. Essentially, you can kind of download the file of these open source models and add them to your computer at no cost. It's virtually free at that point. I mean, the only thing you'll really be paying for is, I guess, GPU usage. For example, recently I went to my father's house and saw that he had a Mac Mini and finally inspired me to buy my own. I've heard stories of people using Mac Minis to add these, local large language models, and I think I might do that myself, only because I think I'm getting tired of paying these large model names, these like I said, the OpenAIs and the Anthropics money to use their models when I can probably get something free of cost that's just as good. It doesn't have to be necessarily from China or stuff like that, but it could just be free of cost. I pay for a Mac Mini, maybe $1,000 plus. And the Mac Mini will pay for itself, and the model will pay for itself, and the only thing I have to keep up with is upgrading that model manually. Meaning, if a new model of that same original model pops out, I update it and get the most recent version of that model. So when we think of closed source, we think of open AI, GPT, Claude, and let's just say, for example, Google Gemini. All three of those closed source ones are big name models that generally everybody knows. Um, and it's not that they have like a huge paying cost, right? I mean, like per million tokens, you might pay few dollars, and not everyone necessarily uses, a million tokens. But let's say like you're running something constant. An open source model can really be helpful if you're running something that needs to be run every day in a 24-hour cycle. Having an open source model is extremely beneficial because, again, it's virtually free, as the only thing you're really paying for is the GPU cost. So open source tends to be very low cost, just $1 sign, while, and that's just if you're doing something just $1 sign 24 hours, right? Again, you're just paying for a GPU and that's it. While closed source usually is, if you're running something 24 hours, I want to put maybe $3 signs here. And maybe you kind of have to multiply these $3 signs by however many tokens per million you're using for whatever your task is over a 24, let's just say example, 24-hour basis. And again, not only are you paying for, and let's just say this is just related to the GPU, you're paying not only for API cost plus GPU cost plus, let's just say, general infrastructure costs, right? Because maybe you have to partner with these models, like the company models, and maybe you have to pay them for support, just in case anything goes wrong. Where again, you can kind of just get an open source, you pay for the GPU, you download the entire model, add it to that, you're good to go. I think one time I even added Llama onto my own PC. It took a long time. This is like, I think it was like a billion parameter, maybe a little bit less than a billion. And it was pretty fairly easy to use. The only thing is that it was really slow, right? Because again, like adding a large language model is going to make your performance very slow when it comes to operating that model. So, like I said, I'm very convinced these days to get a Mac Mini, add a large language model to it, and this way I don't gotta pay anybody for anything. Like it's creating, I think now, this sovereign AI engineer in the future, and I think a lot of other models are gonna follow suit. Where I predict that a lot of these larger companies are gonna have an open source option, maybe where like there is this low hanging fruit model of just like, hey, like this open source model is your general large language model, while we have these other ones that are highly specialized in life sciences, in mathematics. So like you'll have one large language model that's very, very useful, that is open source, and then you will have these, let's just say, I guess you could say like small language models, or you could call them large language models as well. They could be, that are specialized in whatever their case is. So my take simply is, rather than trying to decipher and shop around in multiple instances or multiple cases, why not just experiment at the same time, compare models at the same time, using something called Open Router? Now, this is not, I'm not sponsored by Open Router. This is not me trying to convince you to use Open Router. I'm simply trying to give a lot of life sciences individuals that process a lot of health information, clinical information, stuff like that, a way to compare models to see whatever is the cheapest cost. Because a lot of times, again, coming from someone who has worked in the biotech space as a data scientist, when you're working with these closed models and you recognize how much tokens you're using, you begin to really ask the question whether or not you should scale back, and what is important to process and what is not. Again, when it comes to IPDs, GXP information, analyzing biological data, having that model process millions and maybe even billions of rows within data sets, to then, come up with a prescriptive solution, that can take a lot of tokens and then cost millions, or dare I say billions, down the road. Um, with that being said, here's my solution when it comes to comparing what models could help and what couldn't, or what can't, sorry. So here we have something called Open Router, and it's this ability to kind of scan through all these models. For example, you can go to the most popular and see that, Zomi is this kind of new model that I guess got released, or the most popular model that got released. It might be Chinese. Deepseek, Tencent is something. Nvidia is a popular one, and as you can see, it's free of cost. $0 for inputs tokens, $0 for output tokens per million contexts, which is a steal. If you can just, my thought is, if you can basically add, let's just say you're working with AWS, right? If you can take, let's say you take whatever options AWS has when it comes to GPU usage. You take an EC2 that has GPUs associated with it. You add an open source model to this EC2 that has GPUs associated with it, and you're basically able to have your own sovereign model, right? Again, it's running on AWS's infrastructure, of course, but you're basically only paying for the GPU cost. That's it. That's literally it. Other than that, you don't have to pay API tokens. You don't have to pay for support from like these big brand name models. You simply only pay for the GPU itself. And that sounds way easier, but stuff like these open source models are, a good idea to install. And again, that's just one idea, of what you could do. I'm sure like you could have your own on-prem GPUs if maybe you're a smaller startup, and just do something like that where the overhead literally eliminates itself. You get a bunch of Mac minis. You invest into a bunch of, good, useful Mac minis, add, a few open source models to them, and you virtually have like the ability to, again, have no overhead when it comes to using AI. So just an idea. But what I really want to talk about is, again, Open Router gives you the option to use an API. I get it. Yeah, to an API to where you're able to test out whether or not these different models meet your needs. So, for example, I'm testing Anthropic, OpenAI, Deepseek, and I'm testing it having the ability to summarize a document to then bring about, like, flag anything that looks off or worth double checking and summarize it in 5 bullet points. And it's an example protocol document. Extremely easy to use, nothing crazy. I'm using Databricks right now, using their serverless GPU, but I'm able to take a protocol document that I think maybe is 98,000 tokens supposedly. I think we can check the output later. Run it and compare Anthropic Claude Sonnet 5, GP 5.6 Tera, and DeepSeek V4 Flash to see, number one, how many tokens each model uses if you were to use the API, and number two, how fast it is in the latency, number three, how many tokens it uses total. And we can see that using langsmith. So really and truly, I'm using langsmith and Open Router, and I think you need a LangChain API key as well. I think that's free to use, but the Open Router, for one, you have to pay to use the API itself. You're paying for the token still, so I put like $10 in there, just again for the experimentation. This is not something to use like constantly. It's just only when you want to experiment to see, let's say, to compare whether an open source model performs just as good as a foundational top tier model like Claude Sonnet 5 or GPT 5.6 Tera, right? Which I think this is the new model that got released by OpenAI recently. So once you do that, And I have it to where it's able to output the model, the output, the usage, the latency, prompt tokens used, cost, etc., etc. And as you can see here, using this, again, this is a protocol document that I'm adding to this, and maybe I can show you guys later what that protocol document uses. Matter of fact, I'm gonna show you right now. Let's see. So the protocol document that I'm using is this clinical trial protocol. This is public information here. Protocol number, I think this is an example of a randomized double-blind placebo-controlled study to elevate the safety and efficacy of TJ301 for ulcerative colitis. This is, I think, 96 pages long, I believe. 97. So again, very long document. And it's beneficial to have something or some type of process summarize this for maybe different clinical leaders. And again, that's where Open Router can come in. Give me a second. That's where Open Router can come in to give you the ability to compare multiple models. And I don't think you don't have to only limit it to 3. You can have 5 or 10. I never experienced a limit, so maybe someone can experiment that and see what happens. But you can have multiple models that you can compare against and see, again, the prompt tokens used, or the amount of prompt tokens used, amount of complete tokens and total tokens completely, with the total cost, right? And you can look at the inference, the upstream inference cost, inference prompt cost, etc., etc. And like I said, here we see total tokens used for Claude Sonnet, 230,000, with the cost being 47 cents. And then we have here where we see GPT 5.6 Terra with 94,000, with the cost being looks like 6 cents. And then we have here Deepseek having used 47,000 tokens, with the cost being 19 cents. So again, now obviously we're not seeing the whole output, right? But that's something where you can see, okay, clearly out of both Deepseek and Claude, GPT 5.6 currently gives the most cost efficient model, right? Compared to the 19 cents we see here and the 47 cents we see here from Claude and from Deepseek. Now, again, the main crux of this is, sure, Deepseek might cost 19 cents, which is more than GPT Terra, but Deepseek is something that is open source and you can install locally. You don't have to use the API. The question then becomes, does Deepseek, now that we know that Deepseek can be the cheapest, and now that we know that GPT 5.6 Terra is the cheapest when it comes to API costs out of the 3, does GPT 5.6 Terra and Deepseek give the most relevant output? Right? Is the output comparable? Is it just as good as the 2? Or should we stick with GPT 5.6 Terra for things like this? Since number one, it's cheaper than Anthropic, but is Deepseek, if we want to go the route of just installing it locally, does Deepseek perform the best as GPT 5.6 Terra? And this is again where you just eliminate Claude and now begin, more comparisons between the two. But this boils your choices down, right? From, okay, let's look at the cost. Now that we know which one's the cheapest out of the 2, or out of the 3, let's now see, okay, do they have the same performance? If the local model performs just as good as the closed source model, great. We can just install the open source model locally to our, infrastructure or our GPUs and our servers. If we find out that the open source model that we picked doesn't perform as well as the closed source model, then maybe you probably should go with the closed source since it's probably more specialized in whatever you're doing. Or, you should run more tests or do both. You still use the closed source model, but at the same time, there's open source models constantly being released. Kimi's one, Quen's one, Deepseek is one, Llama's one. Try and see ongoing if there is open source models that then perform the best as 5.6, but it's an ongoing experimentation. So that's a cheaper route instead of, I'm moving towards uh, open source these days versus closed source. And I'm beginning to tell a lot of people that I work with, it's probably better for someone to install a local model to their computer or their servers, um, and then just have someone kind of maintain the updates to it, right? Someone needs to stay updated on whether there's a new model that dropped for it, for whatever their local model that they installed, and really just patch it when needed and stuff like that. That's really the only upkeep that's needed. So I say all that to say, for all my life sciences professionals out there, uh, it's now a crazy time when it comes to all the biological information that's getting poured into AI right now, and all the biological, clinical, life sciences information that AI is processing these days. Try to be more efficient, try to be more cost effective. Local models, open source models now can perform just as good or better than a lot of the closed source models, especially when you give them well thought out prompts, or when you decide to play with the weights and fine tune them. I mean, playing with the weights is something more complex. If you have that knowledge and specialty, go for it. But the options are out there. So I say all that to say it's okay to rage against the machine that we know as the closed source monopolies that I think we're seeing these days. It's okay to rage against the machine and really start using open source models, and come AI sovereign and use whatever you want. Make sure you are make sure you are making these models compete for your usage, because that's what helps a free market, and that's what keeps things competitive, cheap, and interesting. And I say that to say bye bye.